Hello students. So this is my first live class about introduction to gamma function. Okay, so we will talk about why we require gamma function. Okay, what are benefits, and actually we will cover only introductory part. So as you know, this is 23 January 2024. Okay, so we start with the factorial. Factorial is very important function, you know. Okay, so we have 1 factorial is equal to 1. We have 2 factorial is equal to 1 into 2, and that is 2. Likewise, we have 3 factorial, so that is 1 into 2 into 3, and that is 6. तो हमारे पास ये जो फंक्शन है फैक्टोरियल, इसको हम कहाँ यूज कर सकते हैं? इसका बहुत यूज जो है वो कॉम्बिनेटोरियल मैथमेटिक्स में होता है. ठीक है, कॉम्बिनेटोरियल मैथमेटिक्स में आप कैलकुलेट करते हैं नंबर ऑफ वेज यू कैन डू सम वर्क एंड लाइक दैट. सो वहाँ पे फैक्टोरियल फंक्शन का यूज बहुत ज़्यादा होता है. इसके अलावा एक बहुत इंपॉर्टेंट फंक्शन है. खैर, इसकी अगर हम फॉर्मल डेफिनेशन देखें तो फॉर इंटीजर्स the factorial function is defined like by n factorial equals 1 into 2 into 3 into and so on up to n, where n is a natural number. Okay, actually it is we can say for natural numbers, so you can say positive integers. We have this definition. We want to generalize this definition. If we think about some cases where this factorial function is used, we have one great function that is e raised to power x. So if we expand it by Taylor series, for example, we have 1 plus x square by 2 factorial plus x cube by 3 factorial. So we can see here कि हमारे पास फैक्टोरियल फंक्शन जो है वो इसका एक्सपेंशन लिखने में बहुत यूज़फुल है. अगर ये नहीं होता, हम फंक्शंस बेसिकली एक फॉर्मूले के लिए नोटेशन होते हैं, वैसे ही यहाँ पे अगर हमारे पास फैक्टोरियल फंक्शन नहीं होता तो ये एक्सप्रेशन इतना कंसाइज नहीं हो पाता. ओके, सो अगर हमारे पास कुछ जनरलाइज्ड फंक्शन हो जो जहाँ पर हमें एक फैक्टोरियल जैसा फंक्शन हमारे पास एग्जिस्ट करे जो रियल नंबर्स के लिए भी काम करे, और अगर संभव हो तो कॉम्प्लेक्स नंबर्स के लिए भी काम करे, तो ऐसा ही फंक्शन है गामा फंक्शन. जब बच्चों को इंट्रोड्यूस किया जाता है, स्टूडेंट्स को इंट्रोड्यूस किया जाता है गामा फंक्शन, सो वी डिफाइन गामा ऑफ से x is equal to integral 0 to infinity t raised to power x minus 1 e raised to power minus t dt. So this is the way we define gamma function. You can say in any introductory course, this is the way we define gamma function. Here we assume that x is greater than 0. Now you can see that this factorial function which was defined for positive integers only now has a representation like this. but we have not connected these two formulas. Okay, let us connect it. So, what if we have, if x equals n, that is a natural number, in that case we have gamma n is equal to integral 0 to infinity t raised to power n minus 1 e raised to power minus t dt, where n is obviously a natural number. Okay. So, from here what we can do? We can integrate it by parts. Okay. So, let us integrate, and we assume that this is our first function. Okay. So, we are going to integrate this and we are going to differentiate this one. Okay. So, we get e raised to power minus t, and if we integrate this we get t raised to power n divided by n. Similarly, we have a minus sign and integral of this. So, this is from 0 to infinity t raised to power n by n, and we have derivative of this. So, we have e raised to power minus t dt. Okay. So, this is what we got. Again, limits are 0 to infinity. Next, here if you put limits, as limit tends to infinity, so e raised to power minus t is dominant function, and it dominates t raised to power n by n, and it will be 0. In case we check this value at 0, t equals 0. So, at t equals 0 we get 0. So, this is basically 0 minus 0 plus 1 by n integral 0 to infinity t raised to power n e raised to power minus t dt. Well, we can write this integral as 1 by n integral 0 to infinity e t raised to power n plus 1 minus 1, okay, e raised to power minus t dt. So, ultimately we have 1 by n, and this is expression for gamma n plus 1. What we get? We get gamma n plus 1 equals n gamma n. Okay. If we use this recurrence relation, that n plus 1 gamma at n plus 1 is in terms of gamma n, and we expand this recurrence relation. So, what next? Okay. So, we put gamma n plus 1 is equal to n gamma n. Further we have n, this is n minus 1 gamma n minus 1. See, we have expanded this taking gamma in place of this gamma n plus 1, and this thing in place of whatever we have here at right hand side. Okay. So, we have n minus 1 gamma n minus 1. Okay. So, here we can write n minus 2 gamma n minus 2. And continuing this, we have n minus 1, n minus 2, and so on up to 1 and gamma of 1. Let us calculate gamma of 1. So, we have gamma of 1 equals integral 0 to infinity t raised to power 1 minus 1 e raised to power minus t dt. Okay. So, we have integral 0 to infinity e raised to power minus t dt, and its integration is not very hard. We have minus e raised to power minus t integral. Okay. So, limits of this integral are 0 to infinity. Okay, again we have at infinity this is 0. So, this is 0, and as you put 0, so we have minus 1. Okay. So, this is 1. So, we find out that for any integer positive integer, gamma n plus 1 is gamma n plus 1 is equal to n into n minus 1, n minus 2 into and up to this into 1, and this is nothing but n factorial. Okay. So, ultimately we can say that this gamma function is actually a generalization of factorial notation. Okay. But here we can see that this is in the form of integrals. So, we can find out the value of this function for any real number, for that sake any positive real number. Well, this gamma function can be used to find out you can say generalize the value of this factorial up to the complex numbers. Expect some you can expect some of the singularities somewhere. There are some problems like we have problem at 0 and you can say at negative integers. So, that is not part of this video, and I hope you like this explanation of gamma function. In a nutshell, you can say that gamma function is generalization of factorial. Thank you very much.